Sorry, I forgot to unmute. I was talking to myself earlier. Okay, so you watched the first video on diffusion, right? So that's generally how diffusion works. All right, so movement of particles all the time. And when you have a mixture of particles, right? Maybe you start from an area where you have a lot of these molecules or particles. Okay, they're going to spread out because they're always constantly moving. So you saw how they actually spread out, right? So now we are going to look at the factors that affect diffusion. Yeah, so this video is going to tell you, okay, what are the various factors that cause a difference in the rates of diffusion? Okay, so that's about diffusion. Yep, so you already have seen how the particles move, right? I think videos are better than my explanation. Yeah. Without looking at the animation, I think you cannot understand fully. Okay, any questions that you have about diffusion so far? No? Don't have? That's good. So let's start with the worksheet, okay? Now, if I were to look at your responses, all right? See, okay. Some of you make errors. Eldia, you're not so bad, right? In your MCQ. Eldia, any question for this topic? No, okay. So let's start. I think quite an easy chapter also. And it happens every day, no, around us. Okay, this is quite a popular one, right? So you will probably see this question coming out frequently. You might even do this experiment in school. However, it depends because we try not to have bromine gas being released into the atmosphere. Okay, it can be harmful if you breathe it in. Okay, so don't breathe in substances, all right, that are usually colored, I would say. Okay, now a gas jar. Okay, bromine gas is reddish brown. So this is a gas jar that contains brown gas, bromine. Okay, it is placed on top of a gas jar of colorless air. So this is colorless and this is brown. Right? So when the sheet is being removed, bromine gas molecules and air molecules will then mix together, okay, evenly due to diffusion. Already they said evenly, so they are distributed, okay, to an extent where there is equilibrium. You saw in the video the word equilibrium, right? So roughly you will have the same number of particles everywhere, okay, but it's not exactly the same. Like it cannot be exactly the same because they're constantly moving. Okay, like you have seen inside the video, right? So if let's say I have this particular particle here at time 9:26 a.m. Yeah, the next minute is not going to stay at the same place, you know. It can be here, okay, and then it can even move to the other side. You agree now? Okay, so it is constantly moving. They don't stay at the same point, which is why when they are moving about all the time, the colorless gas, which is the air, colorless air particles and the colored bromine particles, they are constantly moving. They are about the same, okay, throughout the containers. So that's why I wanted to show you that video. Okay, answer is C. Nobody got this wrong, but only four of you responded to this. Charmaine, you got this correct? Good. Okay. Who else didn't do? Eldia did it. Okay. Who else didn't do this? Let's see, Bernie. Bernie, you didn't do the worksheet, no, Bernie?
Huh?
How come you didn't do the worksheet?
Oh, I thought I did.
But I didn't see your responses.
Wait, let me check.
Yeah, check. Or do you just do it? You just did it, is that?
I did it yesterday.
Maybe yesterday because I only downloaded. I only downloaded just now though. Did you see your responses in the portal? Because I don't see it.
I need to check.
Yeah, you check. Because I need to know also. Because why? Some of you having problem, like just now you told me his worksheet totally disappeared, right? Huh? Yeah. So luckily I could still see his results as in the worksheet that he has completed. So I can download and send it to him. For yours, it says that you did not do this, no record found. Okay, Bernie, check. I need you.
Lesson expansion and contraction, is it?
No, today our worksheet is on this one. Worksheet 20. Which one did you do?
I did expansion and contraction.
But did you see the date of the tutorial now?
I got it.
God, you mean don't have?
But I didn't know.
There should be, right?
You just show the lesson, then I click on lesson 20, then I do.
You click on lesson 20.
You do the proper one.
Oh, did you do the wrong one?
I think so.
You probably did, let me see, did you do, you said lesson 20. You went to the e-learning. Okay, can you check on this again, Bernie? And complete the worksheet, okay? Once you see this particular lesson, it should be tutorial 20. Okay, Bernie?
Yes.
Okay, good. Okay, so we know that answer is C over here. So what happens to the rate of diffusion as the temperature increases? Okay, so we saw the video, it talked about the factors that affect the rate of diffusion. When temperature increase, what happens to the particles? Thank you, you I saw that. Okay, when temperature increase, so that means there will be more heat energy, right? So heat energy is given to the particles. What happens to the particles? Particles will move faster, isn't it? So when particles move faster, it also means the rate of diffusion will increase. I add a little bit so you take note. So heat energy gained by particles. So particles move faster. And therefore, rate of diffusion increases. All right. Okay, do copy this down. So imagine this is like a open-ended question. All right, and you are supposed to explain what happens to the rate of diffusion as temperature increases. So you need to explain step by step. Okay, when it's about explaining, you need to talk about when the temperature increases, there's more heat energy gained by the particles, causing the particles to move faster. Okay, you can even mention kinetic energy increases, right? Something like that. So kinetic energy increases, rate of diffusion increases. All these come hand in hand. If you don't have the good explanation, then you are not going to be given full marks. Okay. Okay, study the diagram here. What is the process? I mean, we're on this topic, diffusion, right? See, we also saw in the video, in the two different videos, you have seen how when you put, let's say, coloring in water, okay, they gave the example coloring, they also gave perfume, right? So it's not going to stay in one corner or one side of the container or the room, or in this case, the water. It's going to spread evenly throughout. And like I said, they don't stay in their own place. Okay. Can you identify something wrong with this diagram? Can you identify something wrong with this diagram? Youth, can you see anything wrong with the diagram?
No, I can't see.
I think I surfaced this last week or the week before, okay, when we are like, okay, if let's say there is this particular question, it says that there are some air particles, you know, or gas particles in a small box. When these air particles are being transferred into a bigger box, draw the representation, okay, or draw a diagram to show how, okay, the gas particles will behave. Okay, maybe I draw more lah. So when, let's say you're supposed to draw this, right? Okay, when you transfer the same volume of gas into a bigger container, do you think it spreads out to occupy the whole space? Or it's going to stay in one corner? It can't stay in one corner, right? Yeah, it's going to spread out. How? Can I draw something like that? Remember, I said that the teacher will mark you wrong in certain cases. There were a few examples I gave why teacher will mark you wrong. Yes, with you.
Like the circles are irregular.
That's number one. Yeah, must be about the same size, right? What else?
If like the air particles are too regular in the like arrangement, if it's too regular.
Okay, very good. So that's the second one. One more. There's one more actually. So you mentioned you must draw about the same size, right? And it must be round circles. Okay, you have to make sure it's as round as possible. Okay, around the same size, and the arrangement cannot be too regular. Yes, with you. The last one.
The number of the
Correct. Now, do you understand why I said that something is very wrong here? Okay. You see, if I have so much of this coloring, can it suddenly disappear and become a lot lighter? Not possible, isn't it? It's like 2 spoonfuls become 1 spoonful only. You agree? So it's the same thing. You have to take note. There are 3 things you must always remind yourself about particle arrangement. Okay. So take note of all these. This will be very useful to you. In gas, particle arrangement cannot be too regular. Okay, this also applies even if widely spaced. Okay, so just now you saw the way I drew it at first. I was like drawing it like this. Don't you think that this is like too regular? It's not good for you. Don't. Okay, try to adjust a little bit, like maybe this one go a little bit lower. Yeah.